Hello, thank you for watching this product demo. Today we're going to walk through a solution to two common problems that distributed teams everywhere have to deal with. The first is, as a distributed team with developers working all around the world, how can you enable those developers to work faster and focus on their work without the distractions and the hassle of dealing with a VPN client? And the second is just as important. Those developers and the work that they're creating need to share that with other members of your team. And how can we make it seamless for the work they deploy to be immediately and easily accessible by the rest of that team in a secure way that does not have to deal with a VPN client or traditional private network problems? To solve those two categories of issues, we're going to walk through an integration between Cloudflare and GitLab, particularly Cloudflare's zero trust security product, Cloudflare Access, and then GitLab's CI/CD pipeline, as well as its self-managed instance option. My name is Sam Ray. I'm a product manager here at Cloudflare. Also on this demo is Untitled, a senior alliance manager at GitLab.
Thanks for having me, Sam. Super excited to get started.
Like I mentioned earlier, we're going to focus in on two products, Cloudflare Access and GitLab. Cloudflare Access is Cloudflare's zero trust security product. It takes everything we've learned building security features on our network for infrastructure, the types of features like our web application firewall that protect your public facing website, and introduces zero trust identity into anything that you deploy and protect with Cloudflare Access. And the nice thing about that identity is that it can integrate seamlessly with the SSO provider that you already use so that your security teams can build policies that protect anything that you're building in GitLab or your self-managed instance of GitLab itself using the groups and rules that you've already configured in your identity provider. And it can work with more than just one identity provider. If the work that you're building in GitLab and deploying to share with the world needs to be reviewed by members of other teams, you can find alternate options for them to log in as well, while your own team continues to use your corporate identity provider. And ultimately, for your users, whether these are developers doing work over SSH against a GitLab repository that you host, or developers and testers and users all around the world who need to connect to that application that's being deployed, it feels like a SaaS app for anyone and everyone, regardless of where they're doing their work, all secured with Cloudflare's network. I'm going to hand it over to Mayank to talk about GitLab.
Brilliant. Thanks, Sam. And as Sam mentioned, if Cloudflare Access is the bouncer, then you can consider GitLab as the club, particularly for your dispersed developers that rely on GitLab as their single DevOps application to do everything from planning a sprint, building a milestone, and also storing code and operationalizing that code through CI/CD. GitLab itself is a single DevOps platform that your developers use to as a mission critical application to develop applications for their end users that can access apps and services that are deployed through CI/CD, whether it's on Kubernetes or any other platform. Really, what we're talking about today is with Cloudflare Access and GitLab, we want to enable the business for continuous improvement, regardless of where the end user may be and what service they want to access, lowering that barrier of accessibility to mission critical applications with Cloudflare Access and GitLab.
Thanks, Mayank. So in this demo today, we're going to cover two separate but related topics. And before each, we're going to tell you the materials that you need to follow along. The first is very focused around anyone who self-manages their own GitLab instance. The demo covers a deployment in DigitalOcean, but this could be any cloud provider or even on-premise deployment that you have. And in the first part, in that demo, what we want to walk through is how you can use Cloudflare Access to expose your self-managed GitLab instance to your users and your developers without a VPN, but in a secure, zero trust way. So ultimately, your own self-managed GitLab instance will feel like a SaaS app for those users. In the second part, Mayank's going to walk through what it looks like to have an automated CI/CD pipeline where everything that your developers are building and creating in GitLab, whether that's a self-managed instance of GitLab or the SaaS version, is automatically protected by Cloudflare Access. And once protected by Cloudflare Access, users that are connecting to it can log in with your SSO and reach the applications that they need to review and provide feedback or testing on. So I'm going to start by talking through what you'll need for both of these, but we'll break these down a bit more in part one and part two. For the first part of this demo, we're going to be focused on GitLab's double E edition. It's self-managed instance. So you'll need to have a self-managed instance of GitLab running somewhere that you can address and connecting it to Cloudflare. If you don't use your own self-managed instance of GitLab and you only use a SaaS product, you can skip ahead to part two, where for the purposes of this demo, you'll want microservices that you can deploy to a Kubernetes cluster. In both parts, part one and part two, you'll still need a Cloudflare account with an active hostname. That will be the hostname where either your GitLab self-managed instance is made available to your team, or these applications that you're deploying to a Kubernetes cluster are also made accessible to those team members as well. We're going to start with Cloudflare Access. And this is part one of our demo. But first, Cloudflare Access is going to apply to both sections of this walkthrough. So we're going to go into a bit of detail here about how it works. Like I mentioned earlier, Cloudflare Access adds identity into Cloudflare's network. And Cloudflare's network is something that powers some of the world's largest, most popular public-facing websites. And we do that by delivering, serving requests in data centers in 200 cities around the world, putting us extraordinarily close to end users wherever they're connecting. And we're taking that same performance and that same obsession over being close to the end user and having a distributed network, and we're bringing that into Cloudflare Access, our VPN replacement. And with Cloudflare Access, we integrate with your identity provider so that when a request hits Cloudflare's network in one of those 200 cities around the world, we're challenging it for authentication. And the last thing you want to do, and the last thing we want to ask you to do, is to have to recreate your identity provider deployment or your SSO groups. Instead, we just want for those users to feel like they're logging into any other SaaS app when they log in with Cloudflare Access. And once authenticated, we're going to check that user against rules that you configure. And this is the same whether it's the web app flow, users connecting to a web application, or as you'll see later in this demo, users connecting over SSH to, in this case, a GitLab repository. When they're connecting to a web app, it's just a login with the SSO provider. And when they're connecting over SSH, it'll launch a browser window where they'll do the same thing. And in both instances, you not only have that security level of control over who can reach the repository or the applications that you're deploying and protecting, you also get the logging, the comprehensive audit logging, so that you can track down anything that might have gone wrong. And ultimately, all of this is served through Cloudflare's smart routing technology, something that we call Argo. And as part of Argo, the applications that you're deploying, again, whether it's in part two, when you're building applications that are going to be tested and used by users, or it's part one, the GitLab self-managed instance, those are connected to Cloudflare through an outbound only tunnel, which means not only are you adding identity to every request and that identity evaluation, but also you don't need to open up any exposed firewall ports. There's no external IPs required. Everything that you're connecting to Cloudflare for this service is using an outbound only connection to secure that traffic so that you can ensure any requests reaching those deployed applications or your GitLab self-managed instance have been authenticated for identity. So we're going to start with a real demo here. So the first thing we're going to do is actually create access policies. So here in the Cloudflare dashboard, I have a domain, tldworkers.com, which is using Cloudflare's authoritative DNS. Since it's using Cloudflare's authoritative DNS, any request made to this hostname is going to hit Cloudflare's data centers first, which means we can enforce this type of identity rule. But again, with that global distribution, we don't have to worry about adding latency into that. So to enforce that identity rule, the first thing we need to do is integrate with identity. And we make it pretty easy to do that here by adding any one of the more popular providers with dedicated instructions here in the UI, or by making it possible to integrate natively with generic SAML or OIDC. If you don't see your provider here, you can use one of those options to tie in your SSO to this flow. Once we have identity, we want to begin to use that to build an access policy. So I'm going to create an access policy for the GitLab instance that might have previously lived on a private network. I'm going to call this GitLab UI. And I'm going to deploy it as a subdomain of this hostname that I control. And you can repeat this process for other services, things like intranet.hostname.com or ticketing.hostname.com. But we're going to use this particular hostname, GitLab, for the GitLab UI. And we're going to say the demo team is allowed to reach this. And by that, we're going to mean anyone with a cloudflare.com or GitLab.com email domain is able to authenticate through Cloudflare Access and connect to this subdomain. We can build really granular rules if we wanted to, including doing things like using Octo groups or G Suite groups or even GitHub organizations. But for this demo, we'll keep it pretty simple. We're going to hit save. That policy is for the UI, but what about the SSH connections? For SSH connections, you can still enforce SSO requirements through Cloudflare Access by creating a separate policy for that workflow. So we'll have a new policy here, and we'll call it GitLab SSH.hostname.com, and we'll just use the same criteria. Anyone with a Cloudflare.com email address or GitLab.com. And we'll hit save here as well. So now we have two host names, GitLab-SSH, as well as GitLab.tldworkers.com, both of which are being protected by Cloudflare Access, but neither have anything there yet. The next step is to go ahead and connect the instance of GitLab that we have. In this case, it's in DigitalOcean, but this could be on-premise or in AWS or GCP, anywhere that you want to run your GitLab EE infrastructure. You need to connect that to Cloudflare. And we're going to do that with Argo Tunnel. So I'm going to go back and connect directly to the DigitalOcean machine that is powering my GitLab instance. Here I'm connected as root, and I'm going to check to see what's going on this box. I can see that my services are running, and in particular, I have port 22, where SSH connections are being sent, as well as port 80 for the web app. I could use other ports as well, and arbitrary ports for either arbitrary TCP protocols and other use cases, but for right now, we'll just keep it simple and focused on the web app and SSH flow. So the next piece of work here is to connect both of those to Cloudflare with Argo Tunnel. And I've already installed the Cloudflare daemon, something that we call Cloudflare D, on this machine, but I still need to log in and authenticate it so that it can create that connection to this hostname that I control. So to do that, I'm going to run Cloudflare D login, and it creates this URL for me. And I'm going to visit that URL here in my browser, and I'm going to select the hostname that I want to authenticate. I'm going to authorize for the same hostname that we've built the access policies to protect. I'm going to go ahead and click this. Great. So I can now close this window and return back over here to my terminal. And great, I now have the certificate. So the next thing I want to do is connect both the web port as well as the SSH port to Cloudflare. So the first thing I'm going to do is I'm going to start with the web port. And I'm going to run a single command, and this can be run as a service as well, so that you don't have to, of course, run this command every time. I'm going to run it to that host subdomain that we created earlier for the UI. And I'm going to tell Cloudflare D to proxy authenticated traffic to that hostname to this localhost 80 port. I'm going to go ahead and run that. And what it's doing is it's creating two outbound only connections to two of Cloudflare's nearby data centers, in this case, our Amsterdam and Frankfurt data centers. Meanwhile, as an end user, what I'm able to do now is I'm going to visit that URL directly in my browser. Again, no server-side code changes to GitLab yet, nothing that would require any special authentication changes, but I'm going to go directly to that URL here in my browser. And when I visit that URL, I'm instantly presented with this login page with all the identity provider options that we've configured. In this case, I'm just going to go with Google. I'm going to click this. I already have an active Google session in my browser, and I'm redirected to my new instance of GitLab. Of course, this can work with a previously deployed instance as well. So that handles the UI flow. Now I can navigate about this application. Again, I'm connected to that DigitalOcean droplet, but through Argo Tunnel and authenticated through Cloudflare. I don't need to log in again. I can continue to navigate about this application. For me as an end user, it just feels like a SaaS version of GitLab, but as an administrator, I can still control the hosting of it. But what about the SSH flow? So the next thing I want to do is repeat this process for SSH connections. And this is on the host side. Again, I'm connected to this machine that's running there in DigitalOcean. So I'm going to open up a new terminal. I'm still connected to that machine. I'm going to run a similar command, Cloudflare dtunnel. And in this command, what I'm doing is I'm proxying traffic for the other hostname that we had created to port 22 instead of port 80. I'm specifying SSH in the URL as well. So now this is connected for me as an administrator. I now have an HTTP connection from this infrastructure as well as one that can serve SSH traffic. But what about as a client, as an end user? How do I connect over SSH to this machine? And one thing that's important to me is I really don't want to change a lot about my workflow. I just want it to work. I want to, as an end user, be able to use the same commands without any special wrappers as I connect over SSH for things like Git operations and other features. So what I'm going to do here is, as a client, I also have the Cloudflare command line tool, Cloudflare D installed on my client machine. And what I'm going to do is run a separate command to actually print out the SSH config for the instance of GitLab that we just created. So this command is just going to tell Cloudflare D to tell me what to add to my SSH config file. I'm going to copy that. And I'm going to just add it in here. I'm going to save. So now, whenever I run an SSH command towards this particular hostname, it's going to instead proxy it through Cloudflare D, which means I, again, don't need any special SSH config, SSH wrappers or commands. I'm just going to rely on that config file to make sure that traffic for that hostname goes here to Cloudflare D. So now I can come back here and as an end user, with my configuration files set, I can just run a git clone command against this repository. And it's going to launch this browser window for me. And since I have an active G Suite session in my browser already, it's going to say you've successfully authenticated. And meanwhile, I'm going to be able just to continue and proceed as normal here using gitlab-ssh.tldworkers.com as a node host. And I've now cloned what is a very small project there in my GitLab instance. So what we've done here is we've deployed Cloudflare's Argo tunnel, both for the SSH traffic going to our self-managed GitLab instance, as well as the HTTP traffic going to the web UI of the self-managed GitLab instance. We've logged in with an identity provider that we've configured, all without a VPN and all through Cloudflare's smart routing technology and our global network. Up next, we're going to talk about part 2, where we're taking, whether it's a SaaS version of GitLab or the self-managed one that we just protected without a VPN, and all the interesting things that are getting built within GitLab and securing them automatically with Cloudflare Access. I'm going to hand it over to Mike to walk through that section.
Brilliant. Thanks, Sam. Awesome demo. And this is going to be very complementary to what you showcased earlier. Now that developers can access GitLab, whether it's Enterprise Edition or maybe your developers already have .com accounts created, now we'll discuss how you can automatically expose and onboard new applications that are then deployed through CI/CD via GitLab. So think about it this way. A developer catering to a remote end user base will now be able to onboard an application for their end users to access from anywhere using Cloudflare Access. So what we'll cover today in the demo is the actual configuration of the Cloudflare agent as a Kubernetes deployment, i.e. a Kubernetes microservice via GitLab CI/CD. So the first half is going to talk about actually the configuration and setup The second half is actually going to be deploying the Cloudflare Access agent to access those applications that it's going to be front-ending. In this case, we will be actually deploying to GKE, but the service itself that we will be protecting with Cloudflare Access is going to be a private ingress controller that only has a cluster IP. So what you'll need. For this example, I'll be using GitLab.com. But if you have a GitLab EE instance, and maybe you've already protected that with Cloudflare Access, you can use GitLab Self Managed instance as well for this demo. Additionally, you'll need a microservice on a Kubernetes cluster that you wish to access. This is going to be a backend service that you want your end users to be able to log into and access for their daily work. In this example, we'll be focusing on the ingress controller that will handle all the logical routing for any other backend service. So we'll be protecting the ingress controller itself through Cloudflare Access. What I've started with is on GitLab.com, right? That's already a SaaS product. We already front end that authentication. But if you want to then protect a backend application like Tweet app, I've created a project, Cloudflare Access Agent, that you can also refer to and clone to kind of consume for your own use case. So I want to walk you through what this project entails and what's inside of it. This is the Cloudflare Access Agent, which was showcased by Sam, and it pretty much containerizes that whole workflow, the Cloudflare D agent within a Docker container that you can then deploy to, say, Kubernetes, and then point to an internal service like your ingress controller, for example, and then protect your private ingress controller within the cluster and proxy it through the Cloudflare agent. So to give you a quick rundown of what's within this repository and give you a technical overview of how we've kind of created that container and what inputs and commands it uses, the Docker file kind of outlines how we build that binary from scratch, and then we create a container based on the Alpine image to host the Cloudflare D agent. Basically, when this container runs, it's entering in pretty much the same command that Sam outlined in the previous demo, right? It's running the Cloudflare agent, is defining the host name. In this case, it will be our app.tld workers, and that app.tld workers will point to some backend service, in this case, the ingress controller. So anyways, here you define the host name, which has a placeholder for environment variable, and then also the service URL. This is the backend service that you'll be protecting with Cloudflare Agent. And then lastly, the certificate that it will use to authenticate and commit API calls to the Cloudflare managed service. That's the Docker file. I'll now move on to how do you deploy this Docker file and how do you get it running in a Kubernetes as a service? Here's the deployment YAML, which outlines the deployment requirements of this service or this application running on Kubernetes. Here I've specified 3 replicas, which basically outlines, hey, we want 3 pods running at any given time. It's a standard deployment, as you can see here. We've given it a couple of labels and some annotations. This is just metadata, and you can manipulate that to your own requirements. We define the image name that's going to be used. In this case, we're going to build that image every time we kick off a CI/CD workflow. So this image name is going to be dynamic. So you have version control on which container image is being consumed for this deployment. And then here's where you want to take note of how you're specifying those environment variables that the container is going to be consuming to execute that Cloudflare D command. Here we've got the tunnel host name environment variable, and it's defined from the value defined in a secret called CFA origin cert. I'll walk you through how that secret is created within the CI/CD pipeline automatically. Similarly, with a service local URL, that's also stored in the same secret, and that value is also being consumed as part of the deployment. I want to quickly point out instructions on how to consume this repository. The instructions are pretty straightforward. If you have a Kubernetes cluster, you can import it and associate it with this project. What I've done is, as the first step, I've associated the Kubernetes cluster at the group level. And a group in a GitLab is effectively kind of like a folder or a fancy folder with the collection of repositories. In this case, we've got Cloudflare Access Agent and Tweet app. I've gone to Kubernetes and added that cluster so both of my projects have access to deploy services and applications to that GKE cluster. As you can see here, the base domain for that cluster, which is basically the endpoint for all backend services, is tldworkers.com. And that's our domain that we'll be using, or the end users are going to be using to access applications that are deployed by GitLab CI/CD. If I look in the Applications tab, what I went ahead and did was I installed Helm with a single click, and I also installed Ingress Controller with a single click, and I've got an Ingress endpoint. In this example, the public endpoint, but in your example, you can keep a private endpoint or even a cluster IP. That's what we'll be using for this demonstration shortly. So anyways, I've got an Ingress controller and I've got Helm installed. I can deploy applications and front end them with the Ingress, and then later on, I'll deploy the Cloudflare agent to then protect that Ingress controller to proxy any inbound access and basically add a bouncer to the front door. So back to the instructions, I went ahead and added the Kubernetes cluster associated with this project. The second step is to store some of the environment variables that are required to consume some of the information required for the Cloudflare D agent. For example, the origin cert, the tunnel hostname, and the service local URL. So if I go into settings, CI/CD, within the Cloudflare agent access agent repository, and expand the variables component, you can see that I've created a environment variables for the CI/CD runtime environment to consume this CFA origin cert environment variable, which hosts the raw content of my cert that Cloudflare provided when you do the Cloudflare agent login command. So I basically stored that in an environment variable. Similarly, for a service local URL, this is the backend service that is going to be front-ended by your Cloudflare agent. In this case, I'm using a cluster DNS resolution to the Ingress controller. So that nomenclature is pretty much your service name in Kubernetes, dot your namespace in Kubernetes, dot svc, dot cluster, dot local, and whatever port you're exposing. And then lastly, my tunnel hostname, just these three variables where the tunnel hostname defines my endpoint, the URL endpoint that I want my end users to hit to access whatever backend services, in this case, the Nginx Ingress controller. So before we actually kick off this whole process, we want to make sure that our application is deployed, our backend application. So just a quick overview, this is a very simple, basic HTTP website that allows you to repost a tweet on Twitter. All I'm doing is basically deploying a deployment, creating an ingress rule, and in this ingress rule, you'll see that it'll take that app.cloudflare domain, which is the base domain that I define in Kubernetes, which will be TLD workers. So that'll automatically get populated. So that ingress rule will then be consumed by Nginx and then be able to route me accordingly. And then similarly, I've got a deployment service basically that allows you to expose the application. In this case, it's a cluster IP, so the service can't be accessed outside of the cluster anyways. I've went ahead and already kicked off a couple of pipelines. So you can see that this application's already been deployed in this cluster where we packaged and created a cluster, or excuse me, container, and then deployed it into production using kubectl commands. So now that I know my backend service has been deployed, I can then deploy my Cloudflare agent. Order really doesn't matter. If the service isn't back there, you just won't get routed to it. But for the sake of this demo, so it actually works, I'll show you what the CI/CD pipeline looks like, and then I'll kick off a pipeline to kind of show you what it's doing, what it looks like when it's executing. So it creates the container. It's pretty straightforward. It's using Canico to build. And then when it comes to deploying it, it actually creates that secret in this step, right? It takes that runtime environment variable that you defined in settings. It stores it into a cert file. It creates a secret in Kubernetes based on that cert file. And then it updates in those deployment files, the Docker image to use to deploy the host name and the local backend URL that the container will use to kind of get the agent running. And then basically it'll apply any of the YAMLs that are required to do the deployment. So let's go ahead and test it out. So if I go into app.tldworkers.com, and there I am, I'm presented with authentication. So I'll go ahead and log in with my Gmail. And voila, I've got access to the backend service that I deployed on Kubernetes automatically. Now, I do want to point out some architectural considerations when you're deploying Cloudflare Access Agent with Kubernetes. Generally speaking, you have an ingress controller that front ends many backend services. And what you want to do is for every ingress controller, you want to have a one-to-one mapping with the Cloudflare Access Agent. That way you can provide a single entry point and a single bouncer and a single service that can scale elastically alongside your ingress controller service. Now, it is possible where you don't necessarily have to front-end Cloudflare Access Agent to an ingress controller. You could deploy on Kubernetes so long as the Cloudflare Access Agent has access to any LAN-based, or it can route to a backend service, maybe a dedicated VM that's outside of Kubernetes, you can still protect that. Therefore, you can get the whole DevOps experience of managing the lifecycle of the Cloudflare Access agent and controlling the deployments independent of your backend services, whether they are microservices or running on dedicated hosts. So there's various ways of kind of architecting how you want to manage your Cloudflare Access, service tier, but managing it through CI/CD itself and correlating it with projects and services makes it a lot more easier for teams to manage. So what you saw in this demo enabled developers to quickly enable your developer workflows to access applications deployed through GitLab, even on Kubernetes. All they simply had to do was update some configuration on the Cloudflare Access within the repository and point it to the ingress controller, which would then handle your backend logical routing to any additional services. What the Cloudflare Access agent enabled you to do was create a login and authentication policy that whitelisted select users, i.e. your corporation, to access those backend resources. What we wanted to do with this demo is make it easy for teams using GitLabs to automatically deploy QA and staging sites or any other applications to subdomains protected by access immediately. Now, you can get started yourself by simply forking that repo or creating a clone of it and using that as a template to get started. To learn more, please visit developers.cloudflare.com and how you can get started quickly with Cloudflare Access. To learn more about GitLab, visit us at about.gitlab.com. Additionally, if you're looking for more information on part 2 of the demo and access to the repository that I showcased, please check out the video descriptions for the link. And with that, I'd like to thank everyone for watching.